Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to the weekly Teleconnections discussion for 20 November 2020. All right, as I show every week, here are the MJO phases and the areas of enhanced convection. As a reminder, once again, the MJO ranges in phases from 1 to 8, and these numbers equate to areas where there's enhanced convection or rising air motion in the equatorial western Pacific and in the Indian Ocean, where the air is rising rapidly and develops stronger convection and thunderstorm development. Right now, I don't have the latest satellite in this particular presentation this evening, but I did verify earlier this afternoon and noticed that the convection right now is generally located there between the numbers 1 and 2, just a little bit poleward or north of that. Those values 1 and 2 is where the convection is currently fired up across the Indian Ocean. So again, it's always good to go back and verify real-time weather data such as satellite imagery with these different phases for the MJO to match up to see if it's actually happening and occurring. So again, here's phases 1 through 8 for the MJO and where the convection typically forms. Again, I'll show you that temperature composites on the left-hand side of this slide, showing you for the months of November, December, and January, the different phases of the Madden-Julian oscillation or MJO and the subsequent temperature profile across the United States. And again, as a reminder, phases 3 through 6 is generally very mild across much of the nation. Phases 7, 8, and 1. 7, 8, and 1 are the cooler phases as noted by the bluer shading in those particular MJO phases. So what's happening right now? If we look at the image on the right-hand side of this slide on the Gfs Ensemble forecast, you'll notice that green solid line there in the graphic. We're currently in a weak phase 2, MJO phase 2. That's where that larger black dot is located. That green line denotes the forecast for the upcoming period on through 4 December 2020. So you'll notice that that green solid line is showing the forecast for MJO to move into the inner circle. And as I mentioned in previous videos, that inner circle equates to a null phase, or basically the convection across the equatorial western Pacific, west of the date line, all the way into Indian Ocean is basically null. Very minimal impact in that null phase through the 4th of December is the forecast according to the Gfs Ensemble. Moving now to the Gfs Operational Mjo Forecast on the left. This is also out through the 4th of December 2020. Generally, we're looking at a phase 2 currently, a weak phase 2, not very amplified. And the forecast, you can see the blue or the aqua shading, that lighter blue shading, that is also forecasting the MJO to rotate into the null phase, into that inner circle at the center of the diagram, with minimal impact through 4 December. Now the Navy Espc MJO phase diagram on the right-hand side, follow that solid dotted green line there, follow that green line, and according to this model, we're starting out in phase 2 for the MJO, similar to the GFS, and it's rotating into the null phase as well by the 21st. This one runs out, let's see, this one runs out to the 27th of December. It runs from the 16th November to 27th December. So it's very weak. It basically moves into the null phase ultimately, but before it gets to that inner circle, the null phase, it does rotate into a weaker phase 4, 5, and 6 before it moves right back into the null phase. So again, right now, as of looking at the latest data for the MJO, we're not expecting much of an impact from the MJO in such a weakened state. All right, so we'll keep an eye on that because the MJO does have a lot to do with the type of weather we get here in the United States in the winter seasons, and it has played a big part in the past couple winter seasons with the milder phases. All right, now moving ahead to the La Nina update, the latest La Nina update. The graphic on the left shows the latest sea surface temperature anomalies in degrees Celsius You can see the scale there in the vertical, the bluer shading indicating the below normal water temperatures, while the oranges and the red shading indicates above normal water temperatures. So again, the major feature that sticks out is that blue shading extending from the coast of South America westward along the equatorial eastern Pacific latitudes, generally indicating a La Nina phase. You'll notice more of the warmer than normal water temperatures are existing right now up into the North Pacific Ocean, as well as off of parts of the western North Atlantic up through New England, off the coast of Maine. The image on the right shows that blue line there shows the general trend in the water temperatures over time, and we go all the way back to late August with this diagram. It extends all the way out to today's date, November 20th, 2020, and you'll notice around August, in late August, the initial starting point of this graphic, the water temperatures were basically around 0.5 degrees Celsius below normal in the Nino 3.4 region. You notice a major drop-off over time with this blue line, especially between about October 10th through the end of October. We had a major fall-off in the cooling water temperatures in that Nino 3.4 region in the eastern equatorial Pacific. We have made it all the way down as cool as negative 1.6, negative 1.7 degrees Celsius below normal there in the first couple days of November, which would qualify for a strong La Nina phase. But now we saw a little bit of a rebound in the last couple of weeks, where last week we were sitting at about minus 1.1 degrees Celsius below normal. But now, in the recent past 7 days, we see more of a downward trend again to these water temperatures in that particular Nino 3.4 region. So the current value as of today's video is sitting at negative 1.26 degrees Celsius. So we're now in moderate La Nina territory. Generally, the classifications, a weak La Nina is 0.5 to 0.9 degrees Celsius below normal water. The moderate La Nina is from minus 1.0 to minus 1.4 degrees Celsius. And then a strong La Nina phase is considered negative 1.5 degrees Celsius or greater. So again, we're keeping a close eye on this trend in the water temperatures in that part of the world for our upcoming winter weather. Moving on now to the Arctic Oscillation forecast. Again, the different phases, a negative versus positive phase. With a negative phase, high pressure at the polar areas, a major dip in the jet stream, the polar front jet stream, which will usher in much cooler air from the higher latitudes into the Midwest and eastern U.S. With a positive phase AO, however, we now have low pressure up over the north polar areas and more of a west to east, or what we call zonal jet stream. And fast-moving systems, mild air, generally a Pacific air mass from the west to the east coast with more of a positive phase AO. And that's really what we've been seeing recently. We have seen some occasional dips in the polar front jet stream, ushering in just really quick hitting shots of colder air. We just had a shot of colder air, one of the coldest shots of the season this past week, across southeast Virginia anyway, in the mid-Atlantic. But in general, with a positive AO phase, look at that graphic on the right and keep that graphic on the right in mind as I move through the forecast. All right, so let's take a look at the European Deterministic Arctic Oscillation AO forecast. Pay attention to the white dotted line there, the white dots, the white circle. That's the latest forecast, showing we're staying in positive territory all the way out through just shy of the 1st of December. So really no changes according to the European model as far as AO forecast. It's going to remain positive throughout. And a positive AO again, that graphic on the right, positive phase. It's more of a west to east zonal jet stream, mild Pacific air. From the west to the east coast, the coldest air remains up over Canada for the most part, and you get quick moving little disturbances or ripples in the jet stream. Disturbances in the upper atmosphere that move relatively through quickly. No major storm development with that. With the ECMWF EPS Arctic Oscillation, the 50 perturbed members, pay attention to that green line. That's the ensemble mean or the average of all the models, showing a positive phase for the Arctic Oscillation. forecast out through the 5th of December. For the European EPS 50 perturbed members, let's keep going here. Let's take a look at that. Again, a positive phase extending all the way out through early January 2021, just after the new year, the beginning of the new year. And again, the green line says it all. It's a positive phase Arctic oscillation. On the GFS deterministic model, we have a fairly strong Arctic oscillation, strong AO, and a major drop down. You can see how that white circular line really falls out closer to the zero line. Quite a dip from about a positive 3.5 down to 0, and then back up again. It's almost like a roller coaster ride. And then negative, according to the GFS deterministic, the last few days of November into December, but then back positive again. So something to keep an eye on. GFS has been a little bit more bullish on Arctic oscillation, possibly moving into negative territory towards the end of November into early December. The Arctic oscillation, and I'll talk about this more in a bit, is also GFS is also forecasting the polar vortex to somewhat become stretched. But this is the outlier, and what do I mean by outlier is this is one of the only models that is indicating this. You look at the NCEP Gfs version 12, Global Ensemble Forecast System V12, 30 perturbed members in this model. This one runs out to the 6th of December, pretty long range. Look at that green line there. We're in positive territory right now for the AO, dipping down closer to neutral around the 25th, 26th, Thanksgiving, and then it's pretty much neutral then again after the 29th of November through the 6th of December, hanging around that zero line a little bit closer. Moving on to the North Atlantic Oscillation Forecast, the NAO model forecast, positive phase on the left, negative phase on the right of the NAO, and this is the typical type of situations you get with a positive NAO phase, west to east jet stream, more mild air that floods into the United States, west to east. Coldest air remains bottled up over the polar areas, and there's a lack of blocking. With a negative NAO phase, you get a strong blocking into the North Atlantic Ocean, strong upper level ridge into Greenland. That blocking then tends to, what goes up must come down the atmosphere. So on either side of that major upper level ridging into Greenland with a negative NAO, you get a deep dip or a trough in the jet stream pattern, one extending into the eastern U.S. with a stormy pattern. This is where you can get more of those explosive, stronger East Coast storm systems when you get this kind of negative NAO phase set up with blocking downstream up into Greenland. And then on the other side of that into Western Europe, you also get a major dip in the jet stream. So places like Northern Europe may be cooler and drier than normal. All right, so let's take a look at the European deterministic NAO forecast. Follow that the white circles, that line remaining positive throughout the period through 1 December. For the European EPS NAO 50 perturbed members, follow that green line there. That's the ensemble average or ensemble mean. Running out a forecast out through 5 December, positive. NAO is positive. And then the European EPS NAO 50 perturbed members, 46-day forecast. Now we're going all the way past the end of this year into early next year. And look at the green line there, the ensemble mean or average once again. You can kind of see what's going on here. Positive phase of the NAO, and that does not favor the high latitude blocking in the northern oceans. A GFS deterministic forecast for NAO showing a positive phase to close out as we get closer to the end of November, and eventually dipping briefly down to negative territory 30 November, 1 December, but then back positive again beyond the 1st of December. And then the NCEP Gfs V12 NAO 30 perturbed members, look at the ensemble mean, the green line, the average of all the models, showing a positive phase, somewhat closer towards neutral there after the 29th of November for the NCEP Gfs V12. Now onto the PNA, or Pacific North American forecast. This is what you get with a positive PNA on the, positive PNA is going to be on the left, and a negative PNA will be on the right. The blue and purple shading indicates below normal temperatures while the oranges and yellows and greens indicate above average temperatures. So with a positive PNA, you get ridging out in the western U.S. with the warmest temperatures and a trough in the eastern U.S. and colder than normal temperatures. With a negative PNA, we just flip the reverse of that. That's where we get troughing in the western U.S. with cooler, wetter weather out west. Sometimes it's white in the higher elevations of the mountains. And then in the east, with a negative PNA, you get warm air above average temperatures and associated more with that southeast ridge. So let's take a look at the European Deterministic Pna Forecast for 20 November, showing a negative phase of the PNA. Notice that the white circular line there staying below that zero line. That's negative territory. And remaining negative all the way out through about the 27th, 28th of November. And then this model, European Deterministic, says, hey, wait a minute, I'm seeing some change here possibly in the pattern to where we may actually get higher heights and a ridge building in the western U.S. with lowering heights and a trough possibly moving into the eastern U.S. So that's something to keep an eye on. For the European EPS Ensemble Prediction System, 50 perturbed members, notice the green line again. We're in negative territory right on through Thanksgiving, and then next weekend after the Thanksgiving holiday, trending slightly positive to possibly neutral beyond that into early December. Moving on to the European EPS PNA, 50 perturbed members, 46-day forecast. This one goes all the way out to the new year. Look at that green line. Again, positive to start. In this particular, it's negative to start rather, if you look at the far bottom left. Getting ahead of myself. Negative to start, moving into positive territory there in the first few days of December, and then back towards neutral, and then possibly back to negative again. We have seen a major tendency of the PNA to go negative in the heart of the last two winters, where it's, where you get more of a trough, a persistent trough, and the coldest temperatures remaining west of the Mississippi River, and the warmest temperatures east of the Mississippi River. Right, let's take a look at the Gfs Deterministic Pna Forecast. Ooh, this is a roller coaster ride. A lot of ups and downs in that white circular line. We're negative. With a negative PNA, we got those warm temps in that upper level ridge situated off the southeast coast. And then it goes positive. It goes positive in the first part of December, the first week of December. The Gfs Deterministic saying, wait a minute, we can see a pattern change. So both the Gfs Deterministic and the European, they see maybe a possible change in the overall long wave pattern. Last few days of November into the first week of December with more of a positive PNA and a ridge building in the west a little bit and a trough in the east. And then finally the Gfs V12 PNA, 30 perturbed members. Look at that green line, your average ensemble mean. Negative to start, so that makes sense right now. We're getting quick king shouts of cold, but they're quickly replaced by milder air and more of a ridge position off the southeast coast. And then you get a positive PNA over time with this model, which would yield colder temperatures and a trough in the eastern U.S. And that would be the last couple days of November into early December. So the NCEP-GFS is also in concurrence with the Gfs Deterministic as well as the European Deterministic. Moving ahead now to the Eastern Pacific Ocean area for the Eastern Pacific Oscillation Forecast. What happens in the Pacific does not stay in the Pacific. So here we go. Eastern Pacific Oscillation EPO. The graphic on the left shows a negative EPO and Arctic high pressure. See, what happens is with the negative EPO, you get high over low pressure in the Eastern Pacific. With that higher pressure building into Alaska, that will dislodge some of the colder Arctic air off the polar areas down into the lower 48. You get a break-off bubble Arctic high, and with a negative EPO, you're going to be colder generally in the upper Midwest on down actually into the Midwest and Ohio Valley, whereas the positive EPO on the right, look at that mild air with a more west to east jet stream represented by those arrows. Coldest air with a positive EPO remains up over the Arctic. That's typically associated with a stronger polar vortex too. So let's take a look at the European Deterministic EPO forecast. Look at that big hill there on the left part of the diagram. That's a strongly positive EPO at this point. So with the strongly positive EPO, you're going to have a general mild Pacific air mass dominating the U.S. from the west to the east coast with that positive phase. But you notice as we moved, now we're at the 20th of November. Now we're looking ahead, current to ahead. We're mostly neutral with that today, and then it goes positive again, though, before trending slightly negative around Thanksgiving Day. For the European EPS, 50 perturbed members, the green line, the ensemble average, showing a positive phase, positive EPO, warm temps, mild across the U.S. as a whole, with milder Pacific air, and then generally a positive phase, the EPO, after the 27th of November. Okay, so generally positive throughout a lot of this forecast period according to the European Ensemble Prediction System. Now what about the EPS 46-day forecast, 50 perturbed members, out through early January? Look at the green line, positive, positive, positive. All right, so that would indicate milder temperatures, not only in the eastern U.S., but across a good section of the U.S. as a whole. And then the Gfs Deterministic EPO forecast. Wow, look at that positivity, 11 to 16 November. That's in our rearview mirror now as we're on the 20th of November currently. But then you got a lot of ups and downs like a roller coaster, just at one of those theme parks where you get a lot of up and down motion, positive, then slightly negative, then neutral, then back to negative, then back to positive through the early part of December. So this model is a little bit all over the place. And then ahead to the NCEP Gfs V12 EPO 30 perturbed members, 16-day forecast out through the 6th of December. Oh yeah, here we go. We're looking at positive EPOs, milder air across much of the United States, dipping down to negative territory slightly, and around Thanksgiving, and then back up to the positive, slightly positive territory there. They'll close out November into the 1st to the 4th of December. Let's take a look at the polar vortex forecast now. The image on the left, the graphic on the left shows today, currently, and then the graphic on the right goes out in time. Let's see, that's out in time to the 6th of December on the right. All right, I paid really close attention to this polar vortex forecast, this model, this past week. And what I've noticed is GFS tends to stretch, make it more elongated. It's like think about a rubber band, like when you put your fingers in the rubber band and kind of stretch your fingers apart, further apart, you kind of make that like elongation, that oval shape. Well, that's really what this model's been hinting at now pretty consistently the past 5 to 7 days. You notice the circular shape to the white lines. Those white solid lines are your heights, or your geopotential meters. And this is way, way high up in the atmosphere is where we're looking. We're looking for that stratospheric polar vortex. The atmosphere is divided into multiple layers. A troposphere, where all the weather we're used to seeing occurs, is in the troposphere. And then another layer up above that troposphere is what's known as a stratosphere. Now, the stratosphere is a very important component, and you wouldn't think so. But we're looking at temperatures up in the stratosphere. We're looking at the geopotential heights, those white lines and those values associated with the solid white lines now. So what sometimes happens in the wintertime is you get what's known as a sudden stratospheric warming event, SSW event. And when that happens, the temperatures in the stratosphere, that second layer of the atmosphere above us, they tend to warm abruptly over, to sometimes unbelievable levels of warmth up at that high up in the atmosphere. And so sometimes after a sudden stratospheric warming, when those temperatures really, really warm up, you can get really cold air down in the troposphere where we live. So you got to look at the atmosphere in a three-dimensional aspect. But regardless, that can weaken the polar vortex when you get that sudden stratospheric warming. Now take a look at the graphic on the left. That's today. The blue shading indicates the coldest temperatures, and you notice the shape of those white solid lines on the image on the left. That's more circular. But then look at the graphic on the right for the 6th of December. This was the end of the model run, and it's showing more of a stretching out. You notice how it's more of an oval shape now with those white lines, those geopotential height lines. It's more stretched. And look at the blue shading as well there in early December, and how that blue shading, the colder temperatures kind of extend a little bit further south into the United States. So this is something to keep an eye on. It's been fairly consistent. This GFS model for the polar vortex has been fairly consistent. Do conditions favor the weakening of the polar vortex? Not really, but so what happens sometimes is you either get an elongation of the polar vortex or you can actually get a split of the polar vortex. Now, the last time we had a split where the polar vortex was weakened so greatly that it split into two distinct vortex, that happened in January of 2019. And that was very interesting. Some very bone-chilling air where wind chills were 40 to 60 below zero invaded the Midwestern U.S., and parts of New England. The cold air, very intense cold when we get that weakened polar vortex, when it can split, or if it stretches out and gets elongated like that rubber band I was mentioning. But for right now, I'm keeping an eye on that. Overall, though, the vortex remains quite strong. The polar vortex in the stratosphere is quite strong, and it remains over the North Polar areas through early December. That's the latest it looks like. See the blue shading there? The core of that Arctic air is remaining where it normally should be over the North Polar area. All right, so just something to keep an eye on. So here are my final thoughts in tonight's video. I hope you can see this. The font's a little smaller than last week's video. So MJO is currently in weak phase 2, and this is going to trend to null phase through early December. Not expecting much of an impact from the Madden-Julian oscillation. Not a very great amplification. Now, if I went back to that and showed you the MJO real quick, I want to explain one more thing about that MJO. So I'm going to go back to those diagrams. Okay. So look at the graphic on the right, and again, those numbers on the outer part of this phase diagram indicate phase the MJO is in. So the dark black dot indicates we're in phase 2 to start this model. The green represents the actual the average of all the models. And one thing I want to point out about this is the farther away that green line is, the forecast is away from the inner circle. I remember I said the inner circle was your null phase, but the farther away that green line is away from the inner circle, the farther out means the stronger the amplification of the MJO. That would mean that with a stronger MJO, you get more of an impact. Now, I will be updating those temperature composites there on the left. I will be updating those in the next video for December, January, and February, because not all MJO phases act the same. They don't produce the same type of temperature differences from normal throughout the whole year. For example, phase 8 is cold in the winter months for the eastern U.S. However, that will change in the summer months. It may not be as cold. So I will change that and update that. I just wanted to explain that about the MJO. All right, now moving back to my summary and my final thoughts. Whoops, there we go. We do have La Nina conditions continuing across the equatorial eastern Pacific. As I mentioned from that slide, we're sitting at minus 1.2 degrees Celsius, so 1.2 degrees Celsius below normal for those water temperatures in the Nino 3.4 region. So with that, we typically would expect milder temperatures for the mid-Atlantic. We'd expect drier and milder temperatures. Okay. And just over the last week, I've been watching the trends from week to week. The water temperatures have dropped slightly. Not a great drop-off, but we're starting to see a downward trend of those water temperatures again. We're sitting in moderate La Nina territory. Okay. Additionally, models are indicating a positive trend in the AO, the Arctic Oscillation, through early December, with mild temperatures across the eastern U.S. So we're expecting mild temperatures to continue. We really aren't seeing any significant signs of, that's a difference from last week. But we're not expecting at this time any major changes through early December in this overall temperature pattern with the positive AO. Additionally, models are indicating a positive trend in the NAO through early December. So that's going to lead to less blocking at higher latitudes in the oceans, especially in the North Atlantic Ocean. That's going to allow for more progressive weather patterns with faster moving systems. That's exactly what we have going on recently. I've been watching the model runs closely. We're seeing more of a fast movement of the troughs, upper level troughs and ridges. They're moving through fairly quickly from west to east coast of the United States. In other words, your pattern is not getting stuck in place by any stretch. You may have a couple days of cooling down with the temperatures where it gets kind of cold, but then the trough quickly lifts off to the northeast and heads out. And then you get that replaced with a upper level ridge that comes in, and the temperatures moderate in response. So again, we're not expecting any trend of NAO going negative at any point. Additionally, with a positive NAO, you just don't get you don't get the major East Coast storm development. So we wouldn't be expecting or anticipating any major nor'easters at all with a positive NAO. Positive AO, that's keeping the coldest temperatures well removed from the troughs that pass through the pattern. Additionally, models are indicating a negative trend in the Pacific North American pattern through late November. That negative trend favors coldest temps out in the western U.S. with an upper level trough, and the mildest temperatures in the eastern U.S. with an upper level ridge. Now, I always keep an eye on that southeast ridge. It sits, it's that piece of the subtropical ridge. It just sits off the southeast coast in the winter. That has a lot to say about how our temperatures are, believe me. So we're going to have to keep an eye on things. There are some indications I mentioned earlier with European Deterministic as well as Gfs Deterministic that we could see a transition to a positive phase of the PNA in early December. Now, that would change the pattern somewhat. That would put that trough in the colder temperatures further east, and that would shift the higher heights and the upper level ridge could be building up, the heights increasing out in the western U.S. So that's something to keep an eye on with the PNA. So in general, though, we're expecting mild temperatures in the eastern U.S. through late November for the mid-Atlantic, with possible transition to pattern change early December, something to watch. Additionally, models are indicating a positive trend in the EPO through early December that's going to keep mild temperatures across the east, not only the eastern U.S., but the whole U.S. I mean, there's really not going to be much in the way of Arctic air intrusions, any Arctic air outbreaks, if the EPO remains in a positive state. Additionally, the models are indicating a strong polar vortex. Again, we've seen some stretching. I've seen some stretching with it over the last week. We'll have to see how that stretching, what happens, if it continues to get weakened, or will that polar vortex, that stratospheric polar vortex remain strong and over the North Polar area. You're just not going to get any sharp amplitudes or dips in the polar front jet. And there's going to be no major Arctic air intrusions into the lower 48 with a strong polar vortex. That coldest air is going to remain up over the polar areas. All right, so overall assessment based on this week's Teleconnections discussion, all these forecasts I've looked at, we're looking at all teleconnections favoring a milder solution with a lack of strong East Coast storm development through early December. We just don't see any major changes. All these we just ran through. We just went through together here on this presentation. They're all indicating milder phases. Now, I talk about this in my winter forecast quite a bit. I'll talk about the terms constructive interference and destructive interference. With constructive interference, the teleconnections are kind of lining up and complementing each other, whereas with a destructive interference, I may have one teleconnection favoring cold temps, then I have another teleconnection favoring warm temperatures. So the effects are kind of cross-canceled each other, cancel each other out. And that's called destructive interference. All right. So constructive interference is what's happening right now. You're getting a lot of these, a lot of the models, all the teleconnections are pointing towards mild. They're helping to amplify each other. So we really don't see much of a change in the overall assessment for the upcoming forecast through the early part of December. Now, I have looked at models this week, and I'll tell you, GFS, and sometimes Europeans have been hinting at this even, the European Deterministic. I've been looking at GFS and European Deterministic, and these models are hinting at the possibility of waves of cold air coming down from Canada into the eastern U.S. So it's something to bear watching and see if the, number one is a polar vortex weaken, and the second thing is do some of the other teleconnections like the Arctic Oscillation come down and drop off? Because, for example, in a La Nina winter back in 2010, 2011, the Arctic Oscillation just dropped off. It was a milder November, and then the AO dropped off. Even with La Nina, the AO dropped off to strongly negative, and it was a below normal December in the east, and it was a below normal January in the east. So again, these things can flip, these things can change, these teleconnections, this is not in 100%, guarantee at all. When I do my weekly teleconnections discussions each Friday, I'm just looking at what I see for that particular day with the forecast models. But this is subject to change. So I'm kind of getting it's kind of a hard read right now in November. We've had a couple cold shots across the mid-Atlantic of colder air. We've had 2 in the month of November to this point, and really nature's not tipping her hat, basically. So we'll have to see what transpires over the coming weeks. I'm excited. I love winter weather, and I love sharing weather with you at home, wherever you're watching this. I really appreciate your subscription to the Spot On Weather YouTube channel. And please look me up on Facebook. I put forecasts out as well there. Spot On Weather, as well as on Twitter. Take a look at us. And that wraps things up tonight. I do want to let you know that I will be back in 2 weeks. There will be no video next Friday night. But I will be keeping a close eye on things nonetheless. And believe me, if I see some major changes, I will get that information out to you all. So have a great evening, everybody. And since I won't be back next week, I do want to take the time now to wish everybody a very happy Thanksgiving. Most importantly, stay safe and stay healthy with everything going on in the world right now with the coronavirus. Stay safe, stay healthy. Look after each other, and again, very happy Thanksgiving to everybody. Take care, and that wraps it up. Spot On Weather. If we're not spot on, we're not doing it right. Good night, and God bless everybody.